Hello and welcome to the webinar, Borates Add Once. I'm Scott Webb. We have with us today John Bariza from Haviland, who is one of the most creative people in the industry, in my opinion. John is the Great Lakes Regional Sales Manager for Haviland Pool and Spa Company. And I just want to welcome you, John. Thanks for coming. I'm excited to learn more about borates and how they can help us manage our pool chemistry.
Well, Scott, it is great as always. We've known each other a very long time, and it's wonderful to always share a screen with you, even if we are tiny and in the corner. It's a pleasure. So I'm excited to do some training today. I got a lot of ground to cover, and hopefully you folks will enjoy it today. So I think without any further ado, we can get started, right?
Sounds good.
All right, here we go, guys. Thanks for joining us today. I am John Bariza at Haviland Pool and Spa. Been part of the team for 22 years, and we're going to talk about my favorite chemical. The first chemical I add to my pool, I add to all of my friends' pools. It is borates, and we're going to talk a little bit about them in a lot of different ways. So here we go, guys. The agenda today, and we're going to go straight into borates today. Normally, we kind of set this up by talking about water balance and some of those things. And today, we're going to talk about borates and kind of splice in some water balance into that. So we make sure we cover it throughout and not just at the end. We're going to talk about kind of the main reasons why we like borates and what its best effective uses are in terms of balance and sanitizing and a few other things as well. And then we're going to leave some time for some questions that you can have online, and Scott will feed me some of those questions, some of the favorites that he sees today. And if you miss part of this recording, we will be able to share at a later date. And so you'll have a chance to see it, and you'll also have a chance to reach out to me directly if you have any of other questions as well. So here we go, guys. So I am going to move that thing over. We're going to talk about borates. So borates are really key when it comes to water balance. We want water balance to keep pool water, equipment, and swimmers comfortable. That's kind of one of the big reasons for that we love borates. Give me a second. Give me a second. It seems to have froze for a moment. Oh, I'm good. All right. The other thing we want with water balance is that water balance allows sanitizers to function properly. Sanitizers have a very small range where they are both functional and safe for swimmers. So keeping water in balance is key for that. And then we want, again, to talk about controlling water balance and controlling sanitizers at the same level. So this is another way to make sure we don't have to use as much sanitizers in the water. And another key component is keeping people in mind. We, in the chemical world, in the equipment world, we always have to focus on the fact that it's the people in the water that we want to keep safe, comfortable. So no matter what we do with the chemicals, no matter what we do with the equipment, at the end of the day, it's about making sure that the swimmers are comfortable. So that is our goal. So borates, what are they? Borates are mined, typically in Tibet, California, and Chile. They're about 3 million tons refined every year. They pull it out of the ground, and it's called tinconite. If you heat it to 300 degrees Celsius, very, very challenging to do in a home environment, it forms anhydrous borax, which is sodium tetraborate. And then if you add hydrochloric acid, muriatic acid is another name for it, you get the commonly used boric acid, which is a more common form of it used in other industries. So what are these other industries that it's used in? This is something that I always tell when I teach any of my classes. The pool chemical industry seems to be pretty enormous, but if you look at it in the scope of the entire chemical industry, we are a speck. We are a very small component of it. I bring it up when we talk about one of my favorite products from back in the day was lithium hydroxide as a shock. Lithium hydroxide has disappeared because the lithium has gone to the battery industry, and we simply can't compete with that demand. It's available to us at a price, but a price that is beyond the scope of consumers. So borates used in other industries, glass, fiberglass, they add strength and fire protection. They're actually used as a mild antiseptic in eye drops. And in the dry form, they're used as a pesticide and wood preventative. The dry form acts in a totally different way than the liquid form in terms of how it interacts as a pesticide. It's also used in these other different industries, adhesives, agriculture. What you won't see on this list, if you go online and find where borates are used, you will not see the pool industry because that's how far down the pool industry is in terms of its overall chemical usage. But it's kind of ubiquitous in a number of other industries, and it's got a lot of different ways that it can be used. So it's an amazing, amazing product. Borates in the pool industry really started with the John Gervin Company. He actually brought the product and, oh, I'm going to go back one slide, sorry. He's the one that actually patented the product, and you can look this up, patented it in 1984, began the patent process in about 1980 as a treatment for water, wastewater, or sewage. So you can add it as a germicide or oligodynamic treatment. And an oligodynamic treatment, I had to Google this one. I wasn't familiar with that term. I might use it on the old Scrabble board at some point, but it's the process by which you put some of these metals. Think about brass doorknobs. Brass doorknobs secretly have an interesting thing where the brass comes in contact with germs and actually negates them and neutralizes them. It kills the germs in the same way that germs don't grow on certain metals like copper and silver and gold. Borates have that exact quality. So just having borates in the water come in contact with germs can negate them. So it's an interesting product. And John Gervin Company and then his son Don Gervin brought it to the market through the Protein brand back in 1980s. And that's the product line that we're still carrying today. And Don is still down in St. Augustine, Florida. For those guys that know Don, he is doing well, and I'll probably see him in about a month. So let's talk about borates and water balance. We're going to talk about borates in terms of calcium hardness, and we're going to talk about borates in terms of sanitizing here. And we're going to talk about borates in terms of staining, and specifically stain prevention. And all of this, really, we're talking about prevention, preventing things from going wrong. So let's talk about borates and water balance. Borates help keep pH in balance. We want borates to be there so that water remains neutral. So they act as a buffer so that pH doesn't move up and down. We want to stabilize pH. We spend a lot of our time in the pool industry fighting pH bounce, and that is a struggle. And borates do an amazing job of protecting water from pH rises and from pH drops. It works in both directions, similar to alkalinity. We'll talk about that here in a little bit. So pH, it really is the first thing when I teach the long form chemical class. It's the first thing we discuss because we want pH to be in a very, very small range. And pH is so critically important to swimming pool chemistry. It's the measure of the acidity or the basic state of water. It isn't anything. It's just the measure of everything that goes into it. Everything you put in the water has a pH, and then we test that pH at the end of it. So you don't necessarily add pH. You're adding things that affect the pH. It is the measure of the reverse hydrogen, and it's not a concentration, it's hydrogen ion activity. So it's something that needs a little bit of finessing in terms of adding it to the water. And because pH is logarithmic, pH changes that go from 7 to 6 are 10 times more acidic. And then when you drop from 7 to 5, you're 100 times more acidic. So small incremental changes to pH are very, very dramatic. And this is kind of the entire pH range. It's a 0 to 14 range. But when we talk about the pool world, this is literally the pool pH range you want to be in. Here's the full pH range, 0 to 14. This is how narrow you want your pH to be in terms of making sure it's at the quality for your chemistry to work correctly. What happens if your pH gets beyond that range? To the left of that, you start getting into things like your liner can start to wrinkle. You get skin and eye irritation. On the far left of your screen, you're going to start corroding metals like equipment like heaters and start dissolving metals into your pool. As we move to the right side of the screen, you start getting hazy water. You start getting scaling. You start getting your sanitizer stops being effective and you get algae. And then you can get into things where you're actually now depositing those metals onto the surfaces. So on the far right, you can get things like staining. So that's the spectrum. When you move to the left, you're more, obviously it's acidic, and move to the right, it's basic, and you have those effects. But again, this is a little misleading because in actuality, those are all compressed to this range. There are very few times that anyone in the pool industry is going to deal with water, pool water, that has chemistry in it that is outside of these two ranges. It is very difficult to have your pH above 8.5 into the 9s and for your pH to be down at about the 5 range. So this again is the tightest range, even at the extremes that we're going to see. What we really want to worry about, and I highlight this all the time, is this is the double dose of low pH, high chlorine. If you really want to damage your equipment quickly, that's where you want to be. That's where you shorten the life of equipment, is low pH, high chlorine. And that's what we're really trying to avoid in terms of longevity of equipment. So keeping your pH in range and maintaining a lower amount of chlorine are key. And I'll show you how borates really help you with that. What are the effects of improper pH? So at high pH, you get cloudy water, you get scaling at a pH of above 8.3, you get some internal scaling and clogging of equipment, staining, you get some high LSI, and you guys know the effects of that, and very slow disinfection. At a low pH, now we're towards the aggressive water, hyper disinfection, you get damage to equipment. Irritation is the first thing swimmers will probably notice. And as it's supercharging your chlorine, it actually exacerbates the situation by putting more chlorine into the water. So not just the low pH can be irritating, it's the fact that your chlorine is at a higher potency that really affects swimmers. So there's your pH range. Again, we really stress things in the pH when we talk about pH. And this is when I discuss pH, I want you to know these expressions. So at the low end, I think of low pH as aggressive water, dissolving water, corrosive, burning, itching, hyperactive water. Those are low pH. These are acidic water conditions. When we're at the higher pH range, lazy, depositing, cloudy, viscous, hard water, slowing, that's typically on the high range. So we want to be there in the middle to avoid both of these extremes. Here's another big one. So this is scaling and staining. And this is why I love borates for salt chlorine generators. This is the only part I'm going to talk about salt chlorine generators specifically. Salt chlorine generators are such a great way for consumers to constantly add chlorine to the water automatically. That's what they do. So they do that job so extremely well. There's a couple of other things you need to know with salt chlorine generators that can make them more effective at the long term. They are constantly raising your pH. So you've got to always have an acid addition going back into it. You can slow that constant pH rise by adding borates to the water. So you negate how much acid you have to add. Also, salt chlorine generator pools historically will add a level of corrosion to your water and equipment that normal pool water does not have. So it's slightly more corrosive water. You're adding salinity to the water. You're adding a small electrical current to the water. You're naturally getting a slightly more corrosive environment. So you're adding more metals to the water. So you're going to want to add another level of protection. And that, again, is what borates are exceptional for. So it helps fight that pH creep, and it has properties that help fight the amount of staining and scaling. And by the way, because it is an algistat, it actually allows you to run the salt chlorine generator less, so you don't have to add as much chlorine. So there's so many benefits to adding borates to a salt chlorine generator pool. It is probably my favorite application for borates. And for those folks that have salt chlorine generators that want a pool that is hassle-free, adding borates is ideal because you're really only doing it once per year. So when we talk about pH, one of the big reasons that we keep pH in a very tight range, and if folks, if you're looking at this chart, this is what chlorine does in the water in terms of its effectiveness. So if you follow that dotted red line to the upper left, you'll notice that it reaches 100. And if you follow it straight down, you'll see that the pH at 6 means your chlorine is 100% effective. And as we start moving to the right, pH of 6.5, it starts to drop. And a pH of 7, it starts to drop. And by a pH of 7.2, where we want our pool to be on the low end of pH, your chlorine is about 68% effective. So all the chlorine you put in your water is about 68% effective. And then when we get to the high end, 7.6, your chlorine drops to about 45% effectiveness. And you notice when you get above that, you drop off precipitously where chlorine stops being effective. We need to keep our pH within that very tight 7.2 to 7.6 range to make sure that your chlorine is working at its best. Why don't we keep pH at a lower than 7.2 and get the most effectiveness out of chlorine? Because again, we have these dang swimmers in our pool, these human beings that do not like having their skin and eyes burned. So they need to be comfortable. If we could just keep swimmers out of pool, the chemical guys would be so much happier. But that 7.2 to 7.6, it is a very tight range. So if you're constantly running your pH, hey, my pH is at 7.6 all the time. Well, there might be times within the day, the week, the month that you're outside of that normal statistical range, and suddenly your chlorine isn't as effective. And sometimes in isolated situation or pockets of your water, you might add a chemical and your pH suddenly is above 8 to 8.5, and you might get some localized scaling or staining in those areas because the pH has risen that high. So pH being in this very tight range is key to proper water. So borates and sanitizing, that's why we like borates, because borates help maintain pH within that range. It is a very small range, and anything we can do to help maintain that without constantly testing and monitoring and adding 4 or 5 times a day, which we don't want, borates help keep that water within that range. And that's why sanitizing and borates is important. It's also an algistat. So it's there preventing algae from growing so that your chlorine can work on other things. And we'll talk about sanitizing here towards the end as well. We got a couple slides on that I like. And since borate doesn't leave the water and doesn't become combined like chlorine can and does, then you really, once you add it, it's constantly doing its job, and that you don't have to monitor some of the side effects of it. So we love it a lot for not necessarily sanitizing, but allowing your sanitizer to do the best that it can without getting tied up with these other things. Let's talk about borates and cyanuric acid. Cyanuric acid, in about 2019, I remember, Scott, you hosted a live forum debate at, I want to say it was Atlantic City, and it could have been Vegas.
Oh,
And we were having all kinds of conversations about how much cyanuric acid should be in the water and what. But here's how borates help with cyanuric acid. Now, I want to put this out right now. We are not removing cyanuric acid by way of borates. We're just talking about how we can maintain a lower cyanuric acid level through some best practices. And what does that mean? Because cyanuric acid allows chlorine to stay in the water and neutralize future contaminants, we like cyanuric acid at a certain level in the water. A 30 to 50 cyanuric acid level is perfectly fine and is really recommended so that that chlorine doesn't get burned up by UV. So that level of cyanuric acid in the water is very comfortable, and it rises above that. We do have a few more challenges in terms of slowing down chlorine, but it's not anything that we can't overcome. By adding borates to the water, it works as an algistat. So again, we're preventing algae from blooming. We're preventing future algae from taking over the water. And if we can do that, what does your chlorine go after the most? It tends to go after that algae. That's a nuisance. It's always in your water. Your chlorine is always going after it. So if you're adding chlorine, if you're adding a stabilized chlorine to constantly fight algae in your water or the potential for algae, well, let's add another product to your water that deals with much of those algae issues so that you don't have to treat, you're not adding all this excessive chlorine to go after the algae. And now you allow chlorine as a residual to be in your water to go after the real harmful things that could potentially be in your water. So instead of making sure we're preventing something that's a nuisance, let's handle that with something that doesn't add to your cyanuric acid level. So a great way to, over the course of a summer, try to keep that cyanuric acid level down, especially if you're an exclusive stabilized chlorine user. Borates in your water can really greatly reduce how much you're adding to your pool.
John, we've had a couple good questions. I just want to break in real quick. You mentioned how CYA affects the effectiveness of chlorine, but can you add in the effects of pH? The question is, does CYA affect the chlorine effectiveness related to pH? You mentioned how both those factors affect chlorine. How do they work together?
So if you're on the higher end of the pH range in general with any chlorine, you're starting to slow down how much of that chlorine potency is in the water. So naturally, if you're at the high end, whether it's stabilized or unstabilized, whether it has cyanuric acid or not, if you're at the higher end of the range, you're going to start slowing down how much that chlorine is working in the water. As you get above the 30 to 50 parts per million of cyanuric acid, I talk to people about, think about cyanuric acid as a basket that has gathered up the chlorine. And so it has all of these chlorine elements in it. And now it's dosing it out one after another out of the basket. And it can only dose out at a certain speed. And the more cyanuric acid it has in there, the slower it doses that out. Now, if it's dosing out chlorine at a higher pH, that chlorine that's now being dosed out slowly is now slow on its own. It's naturally slow. So you're kind of getting that double dip, high cyanuric acid, high pH. You're very much slowing down the effectiveness of that chlorine. So it is definitely a challenge if you've got a high pH environment and you've got a high cyanuric acid environment. You're definitely getting a lot less out of your chlorine that someone that doesn't have either of those situations. So high chlorine and high cyanuric acid. And if you're prone to algae, that's definitely one we need to be concerned about for sure.
One more and then we'll keep going. And we'll try to get whatever questions that we get that we can't get to today. We can do those individually after the webinar. But the second question I thought was interesting. It relates to how borates retard the rise in pH that you mentioned earlier. Is the amount of borate, so we're really talking about the amount of borate, does more borate retard the pH rise more, or is it just kind of you have some level and that gives you all the effect that you need?
No, we definitely, the more of the borate and boron ion that's in the water, the more that we'll add as a buffer, much like a typical alkalinity product. It works in the exact same way. The more you add it, the more it locks in your pH. We're going to talk a little bit more when we talk about adding borates to it, but that's a good question because yes, the more you add to it, the more it acts as has buffering properties to it with a limit. And that limit isn't necessarily set by its effectiveness. We do have some governmental regulations on how much of the product, just like the amount of chlorine you should have in your water, there's an amount of borates you should have in your water to make sure that it's both comfortable for swimmers but safe for swimmers. So yeah, there's definitely a target amount, and we'll touch on that here in a little bit.
Sounds good.
Cool. So let's talk about alkalinity when we do a lot of these classes. Alkalinity is more and more as I'm teaching the classes, more and more as I speak with folks out there. I've mentioned about pH being the most important thing. Boy, alkalinity, it might be now the first thing I talk about. This one is a struggle for me because I say that pH is the most important thing, but alkalinity's job is to hold pH in place. And it really, if you get your pH right and your alkalinity is not in range, then all of the good you did to get pH in place means nothing. So realistically, getting your alkalinity right and then introducing the correct pH, it's a better way almost to explain it. But pH has always been the number one on these presentations, and I may finally change it this year. But total alkalinity is what buffers the water from your having those pH changes. It's stuff. It is physical carbonate elements that go into your water that prevent pH from bouncing around so dramatically. pH is essentially like a feather in the wind. It goes whichever way. If you don't have enough buffering in your water, pH will rise when it's an acid, or it'll rise when a high pH product is introduced. pH will drop when a low pH product is introduced to your water, and it is hard to move back. But with total alkalinity in place, that drift dramatically slows down. So alkalinity is as big a deal, if not bigger, because it holds your pH in place. And that's its only job. Its only job is to make sure your pH stays in place. So we definitely need it at the right range in the water. Here's the effects of low pH or low alkalinity and high alkalinity. So on the high side, this is the risk. So we do definitely want a correct amount of our alkalinity level. But if we get too high, we get into these cloudy water situations, especially as folks know, when you add a bunch of alkaline products at one time, you're going to have cloudy water, and you could have cloudy water for a significant amount of time. That on its own is not necessarily an issue. But if you continue to have cloudy water, now you might mask what could be another problem hidden by cloudy water. So we definitely have an issue with high alkalinity in cloudy water. You can get surface scaling, you can get internal scaling, much like the same problems you had with high pH. And also, you can have so much alkalinity in your water, it can be an absolute challenge to lower your pH at that point, because you really have to overcome the amount of alkalinity in your water. Alkalinity, let's think about it as alkalinity as a big winter jacket in your car, and you got the air conditioning on. That alkalinity, that jacket, the air conditioning can't get through. It takes forever to get through. It's a barrier to that changing. So we definitely want to make sure that we don't have too much alkalinity in your water above the normal range. Otherwise, it's hard to adjust pH. And on the low side, now we get pH swings. You can get damage to equipment because your pH is low. So we definitely want to keep alkalinity on the lower side. It's a fairly easy range to maintain. Luckily or hopefully, you're in an area where the alkalinity of the water, the source water you're adding to the pool, is good. I talked to a lot of folks. I talked to a lot of folks in mid to central Ohio is one of my territories. And boy, there's some alkalinity coming out of the pipe in the 200 ranges. And that is a challenge. That is a challenge just day one when you fill that pool with that water, and now you're fighting it constantly. And during the summer, as we're adding water back, that water is just it's just not what you want to be adding to that swimming pool environment, but that's all you have. So alkalinity can be a challenge, and hopefully your source water is of a good and more neutral alkalinity. Here's another example of why alkalinity is important. Here's pHs. There's 3 of them you see on the screen. Not all pHs are the same. So your pH on the left, your skinny guy, is at a pH of 7.4. he is not resistant to change. That pH, if you get a weather event, if you get a storm, if you get swimmers, he can't resist that change. He will collapse under that introduction of any other new pH. The problem is his alkalinity is too low. The proper alkalinity range, we'll talk about it at the end. I save it for the end, but the proper range is 80 to 120. If your alkalinity is only 40, that is a very weak pH. It's identical to the other two, but it's very weak. It's bound to collapse. It'll drop if an acid is added, and it'll skyrocket if a high pH product is added. That is a very, very weak pH. Here's a pH of 7.4. It's like me and you. It's dad bod guy. It's sort of strong, kind of strong. Your kids think it's strong. It's a normal pH and a normal alkalinity. So it can resist some of these changes. So your pH isn't bouncing all over the place. Guy on the right, we hate that guy in person. But in this example, your alkalinity is at 100, but your borates are now at 50 parts per million. Now, when you have a weather event, when you have a pool party, and normally, oh my gosh, my pH is going to go all over the place. Not in this situation. It's so strong. It resists change so dramatically that you're never going to have to really fight pH nearly as much as you would at those other levels. Let me give you a real world example. I pulled this from Mr. Bob Lowry, who we lost a couple of years ago, and spoke a lot about borates in his presentations. In this example, and I've said this, Scott, earlier, because I know a lot of folks are watching this on their phones. This is a little busy, and I apologize for it, but I'm going to try to explain it as well. We're going to lower pH from 8 to 7.5, and we're starting at 160 parts per million of alkalinity. So in this example, I'm going to lower my pH by about 0.5, and it's going to take 28 ounces of pH decreaser to do that. All right, you got it? So we're lowering by 0.5, and it takes about 28 ounces of pH decreaser. Normal scenario. If I add cyanuric acid to the equation, cyanuric acid is also a secondary buffer. It's not that strong, but in this scenario, same scenario, instead of taking 28 ounces, it takes a little bit more. So it's a little more resistant to change. Are we following that? So now that we have cyanuric acid in the water, now it's a little more resistant to change to move that pH. Let's do this combination. This is 50 parts per million cyanuric acid and 50 parts per million borates. So now in this scenario, you'll notice in our first one, we were going from 28 ounces, our first row, and now we're going to 66 ounces. I mean, you're talking about a 60% increase in the amount of chemistry needed to move that change, to move that pH. Well, what we realize in this is if it takes so much to move it, then if it's added to the water via a storm, via rain, via swimmers, that if we add 66 ounces during a swimming event, it would dramatically change what your pH would be without borates in the water. So it resists the change by more than 50% over without having cyanuric acid and without having borates in the water. That's what we talk about in real world, and it works in both directions. So if we were raising pH from 7 to 7.5, for example, these exact same scenarios would come up where it's resistant to change at an extremely high amount. So we definitely like borates just for its added double buffering capabilities. That's probably the number one reason we put it in the water. Here's another reason why we add borates to the water, because water is a monster. Why is water a monster? Mainly water is a monster, and this is really for plaster folks, but it affects everyone, is that water desperately wants minerals. It cannot resist minerals, and it will take them from anywhere. If you don't have enough calcium or minerals in your water, specifically calcium, then it will pull them from anything. Plaster folks realize that if you don't have enough calcium in your water, it will literally dissolve the walls. It'll dissolve the finish. You get etching in your pool surfaces, and you get some real damage. That's why folks, especially in the plaster world, will add extra calcium to the curing process so that you can run the risk slightly of getting some scaling, but at least you're not physically permanently etching and damaging your pool surfaces. If you're in a vinyl liner world and you don't have enough calcium, it definitely will shorten the life of your liner and your equipment because water will pull minerals from anything, and there are minerals within your equipment and there are minerals within the makeup of your liner that will shorten the life of it. A lot of folks have lived and grown up in a pool where the calcium was literally never added to their swimming pool. And you can absolutely have a swimming pool, especially a liner pool that has very low calcium in it. You're just simply going to be changing out your liner at a more often than you would with someone else who had calcium in the water. So adding that correct amount of calcium protects your pool surfaces from the water that's within it. And there are all the bullet points I just talked about. Let's talk about borates and calcium. Borates work by complexing excess calcium. So one of the another reasons that I like having borates in the water in terms of preventatives is that as it's complexing calcium, it means it's holding calcium in solution. So if you do have a little excess calcium, if you do have a slightly higher pH, borates do a great job of adding one more layer that prevents that calcium from coming out of solution and adding to your scaling problem. They work sort of like a metal and scale product, maybe not quite to that degree, but they help with that process, especially with the scaling, especially with the calcium. We know a lot of folks, there are startups that use calcium or that use borates as part of the plaster startups as a complementary buffer and as a calcium net. If you folks want to know more about that, get with the Plaster Council folks. Those guys have so much information, and they are amazing, amazing folks. If you want to learn anything about plaster and startups, those guys are amazing. Also, borates have a water softening property. That's the first thing swimmers are going to notice, that if you feel the water, if you dip your hand into the water of a borate pool, it will feel like literally feel like you've added a moisturizer to your water. It will feel slightly like your water is slippery. And so if you have a lot of calcium in your water, and by adding calcium into your water, you're actually creating an unnaturally high hardness of your water. Well, that can be a little bit drying. Borates kind of offset that by adding that slippery, that lotion-like feel to your water. So they do a great job of kind of making the water feel amazing. Let's talk about borates and swimmers. Like we just talked about, they soften the water so you get that silky, smooth feel. It's almost the first thing swimmers will notice when they get into a borate pool. They're only added once. This presentation is once per year. And we'll show you in a little bit what that actually means when we do some of the numbers. But you add it once per year. It's there. It doesn't go away. It doesn't have to be reset. You don't have to calibrate it. You add it to the water. And if you're gone on a long weekend and you haven't had a chance to skim the pool or you haven't had a chance to do anything to the pool, borates are there as an algistat. Borates are there to make sure your water and your other chemicals are doing what they're supposed to do. They also will add an amazing amount of clarity and sparkle to the water, and you will notice it. I really, really like when some of my dealers out there will have two display pools, one with borates and one without borates. I will say it's impossible to get the clarity and sparkle out of the non-borate pool than you will out of the borate pool. It is definitely something that you notice. Borates in winter, one of my favorite uses for borate. It is a natural algistat. So you put it into the water and it will work to help prevent algae not only over the winter, and over the winter, it's not as important. It's when you start to open that pool and you get a few more warm days than you were expecting. And now it's April and it's 75 degrees and you've got the cover on your pool and the pool water is warm. That's when that borate that you added back or has been in your water since September and October, that's when that borate does its job because it's preventing that algae bloom, that initial algae bloom that can happen because there's no sanitizer in your water. The sanitizer you're adding to your water on closing in days, weeks, maybe a month is completely gone from your water. So that time period when the water rises in temperature, when you're opening, that's when you need borates in your water to prevent that algae. We love it for that. We love it for the fact that it protects surfaces. It does a great job of acting as a buffer to make sure pH is correct in case anything gets under the water, that it protects surfaces. It's a stain preventative because it can help tie up some of that calcium. So we know a lot of folks that, especially will open up that plaster pool in the spring and all of a sudden we have all of these scaling issues, especially on a 1 or 2 year old plaster pool that is more susceptible to scaling. It's a great way to prevent that. And it doesn't do any additional harm. There are some products that you can add in the winter. We know a lot of folks that will try to overdose their pool with chlorine because, oh, I don't want to have a green pool when you open. Well, you throw a lot of chlorine in your pool in a stagnant body of water that isn't moving, and now you've got chlorine dissipating into a specific spot, and now we could do extra harm. We could damage liners or equipment or do other things like that. Borates has no issues like that. And it lasts all off season. It just never goes away. It never stops doing what it does. It's tremendous for that. Great, great winter product. One of my favorites. And now we've talked a lot about how amazing Borates is, but I want you to understand that Borates just can't do it alone. And you can't have a borate only pool. Although, Scott, I'm telling you right now, I'm going to try this next year. I'm going to see how long I can go without adding a chlorine tab because this late summer, fall, my pool is currently open. I'm in Michigan. From August 1st to today, my pool is run on exactly 2 chlorine tabs. And it's 85 degrees today. It's exactly 2 chlorine tabs. And I run my filter 24/7 and I have borates in my water. And I add a little bit of clarifier, and that's kind of my magic formula. Can I add no chlorine? I don't recommend it, but that's what we're going to try. But when we talk about borates, I want you to think about it as that complete breakfast from your Saturday morning. And yes, no one in their right mind has ever had this much food for breakfast. Who's drinking that glass of milk after the cereal with the toast? But I want you to think of borates as part of a complete prevention program. If you are serious about having your pool or your customers' pools use less chlorine and have lower cyanuric acid levels and are as clean as they possibly could be and maintenance free, here's the complete prevention program that I like, along with borates. Let's talk about preventing airborne contaminants from getting in your water by use of covers, either automatic covers or manual covers. The less things you can put in your water, the better. Let's talk about when we're discussing the plantings around a pool. I tell folks if you can see a tree from your pool, it's too close to the pool. Let's think about what is getting into your pool airborne. And if it gets into your pool, let's get it out of your pool immediately. So filtration is a big thing. We'll talk about that here. Don't let them cause a problem. So if it gets into your pool, skim, brush, empty out those baskets, and then filter, filter, filter. Something I've kind of come around to is, boy, do I love robots in your water doing all that great cleaning. There's a number of great manufacturers of those, and they really do a great job. And for a long time, I kind of poo-pooed the idea of having these robots that float on the top and skim the surfaces, and that it felt like kind of a hat on a hat. Like it seems like a little bit excessive. But boy, everything that enters your water comes from the surface. And if you can get it out of your water at the surface level, instead of scouring the entire body of water, you're really getting it at the source. So yes, if you can skim it out of the water, but if you can and get it off the top of your water by skimming it, by using a robot, or by constantly filtering it, it stops it from getting into the water where it's now taking up the entire body and then eventually setting on the floor. So yeah, getting rid of the stuff that gets into your water, pulling it out as fast as you can is a great way to have a complete prevention program. Prevent water contaminants. This is another big one. This is hygiene for me. Make sure your swimmers are clean. Make sure your pets are clean. Better than that, make sure your pets don't go in the water. Test frequently, sort of frequently, for trends. I don't want people testing twice a day, 3 times a day, but test on a regular basis. Make necessary or predictive adjustments. Things like if you have a salt chlorine generator, your pH is going to constantly be going up. Maybe let's get ahead of it, so don't wait for the pH to go up and adjust it. Make sure you're adding acid in there first so that you don't have that adjustment. And then what can you do to automate? What can you do to put on a routine process? Automation is the wave of the future in the pool world. What else can you automate so that homeowners or the service guy that's coming once a week isn't making a big adjustment every Friday? We're making small adjustments so we don't run into problems. All right, let's get into some of the numbers. What's your ideal borate limit? It's 30 ideal borate level. It's 30 to 50 parts per million. 50 parts per million is the EPA standard maximum number, and 50 parts per million is just the best number to be at. It's about 3 pounds per thousand, and you will notice all of the changes. For folks that are wanting to introduce it to a swimming pool, one of their customers' pool, if you add it at the 30 parts per million, yes, you will see some of these noticeable things. You'll see the water will look better, the water will feel better. At 50, the consumer will dramatically notice the difference. That water feels amazing. That water is more comfortable if it gets in my eyes. That water has an amazing sparkle. 30 to 50 parts per million is the ideal range, and 50 is just the one that consumers will notice right away. How do we add it to the water? Let's talk about it, how we get it into the water. And be aware of this. Borates are not a problem solver. They are a problem preventer. So they're never an emergency. If somebody is saying, I need to add borates to this consumer's water, I get it as a service guy. We're not going to be able to add it over the course of every day for the next 4 days. But it is something that you could add on every weekly or biweekly service call and add a little bit at a time. So we definitely could consider being more patient with it instead of adding it at one time. So here's what we talk about. So since borates never leave the water, and here's an example. We got a 20,000 gallon pool, and we're going to run it for about 26 weeks. 26 weeks is a little more than 6 months. That's a lot of weeks for some folks. It's for people in the South, and maybe not a full season. Over those 26 weeks, let's consider 13 backwashes over the typical life cycle with your filter. So over that typical time, if you've got a sand filter, you're doing 13 backwashes, and the approximate amount of gallons in a backwash is 300 gallons. I did a little research. It's a little bit, it can be more, it can be less. 300s average from what the research says. So over that time period, 13 weeks, 300 gallons, you're losing about 4,000 gallons of water via backwash that you need to replace. So about 1/5, 20%. So over the course of a summer, if you start at 50 parts per million borates, you're going to be down to 40 parts per million borates at the end of the summer based on this. So based on all the water you've lost, you're still realistically in the heart of your borate range. So if you've added 50 parts per million of borates to your water year one, fresh body of water, you've never added borates, you've added 50, at the end of the year, you're at 40. So that means when you start up next year, all you have to do is add back that 10 parts per million. And guess what? Next year, you're going to add back just that 10 parts per million. You're just topping it off year after year. So you're never, that initial cost, that initial investment that some folks are hesitant to invest in, after year one, that it's 1/5, it's automatically. You might lose water in other ways. Maybe you have a leak. Maybe you have kids shoveling water out of the pool, but it's the only way that borates leave the water. It does not break down, it does not react in a way that it stops working. It simply leaves the water primarily through backwash. All right, let's talk about adding borates. This is one of a few slides. Borates, one, rarely need to be tested. Typically, I will test the borates in my pool when I open it. I'll add the calculated amount that I need to add back, and then I will never test it again until 12 months later. Since it never leaves the water, I find there is no practical need to test for the amount of borates in my water. So it rarely needs to be tested, and you can test it with the testing people have great strips. You can get a spin disc. Borates are super easy to test, but they very infrequently need to be tested. They dissolve quickly. So practical use, they dissolve quickly, but there are times where there's undissolved components for a period of time. So maybe it doesn't dissolve in 1 minute, it'll dissolve in 10 minutes. But that undissolved material, unlike some other products, pH and maybe some chlorines, it's not an issue. So it's sitting on your liner while it hasn't dissolved. Maybe you've got colder water and it's dissolving slowly. It won't cause an issue. We definitely want to brush it in and make sure it gets into solution. And you could always add the product to water. I add almost everything to water, even liquid products I'll add to water so that I can spread it into my pool. But having those undissolved borate materials sitting on the bottom of your pool for a short period of time, even a long period of time, don't have any issues. And something that you need to be aware of, borates, especially the pH borate blends, things like our Protein Supreme Plus, they're hydroscopic. So they can naturally, over time, absorb water. Hydroscopic means they absorb water. When they absorb water, let's think about them as like if you bake it all, if you know brown sugar is kind of a free-flowing material. As it absorbs water, it can get a little hard and crusty and needs to be broken up a little bit. It's a natural trait of these borate blends. So as they get older in age, or as they are in areas where it's much more humid, you might have some hardness of this product. So it is definitely something to be aware of. If you want to look at it as a negative trait of a borate product, I would agree. It is something that at times it can get hard. It will all dissolve back into solution, and it may dissolve a little slower. One of our guys on the in the Atlantic Coast area, in Boston area, one of our sales rep, did an experiment where he had a bucket of borates that had completely hardened, and he put the entire bucket underwater, and in about an hour, that entire fully hardened bucket of borates completely dissolved. So even the worst case possible scenario, the product still functions 100% as it did when it was free flowing, but it definitely has the potential of getting hard. So we definitely have to consider that, especially with the blended products. They can harden, but they will dissolve. Let's talk about the sodium tetraborate type products. These are the Supremes, our Durachlor activator. These products, when you add them to the water, when you're talking about practical use, they increase both pH and alkalinity fairly significantly. So be aware of that. A 50-pound Protein Supreme added to the water requires about 4 gallons of muriatic acid to adjust for that. So I'm doing a 50 parts per million and 17,000 gallons because that's exactly just about exactly 3 pounds per thousand. So it's an easy recommendation math for me to do. But if you add a 50-pound borate to the water, a Supreme, a tetraborate product, you're going to need about 4 gallons of muriatic acid to adjust for that, because that's how much the pH and alkalinity will rise. So that's just something you need to be aware of. The reason you may prefer a sodium tetraborate over a blended is that Protein Supreme is an EPA registered algistat. You can make that claim as a reseller of the product. Haviland can make that claim and say Supreme or Activator is a EPA registered product. The products that are pH neutral or blended are not currently pH registered to make that claim. So they are borate products, but we cannot make the claim that they are an algistat because that EPA requires that very specific wording. Well, here's the thing that I talk about is a tip that I always like to tell folks when adding these products is because borates lock in pH so well that we have this situation where you've added all the borates. Now you're adjusting the pH after the fact, after you've added a series of locks to it, that let's try to make some of those adjustments first if we can. Let's bring the pH on the very low end of the spectrum so that when we add it, it brings it up to where we want it to be, or maybe slightly higher, so we now don't have to make quite as big an adjustment. That's just a practical tip that I always think about when I add these products. Instructions may vary slightly from that, but I always like to have my pH a little bit or significantly on the lower end, especially if I'm adding a product that has a big pH swing to it. So if we're adding the blended products, so we just talked about the tetraborate, and these are the blended ones, the Supreme Plus. These are pH neutral, very close to 7 pH when you add it to the water. You will see a slight alkalinity increase, typically in the 20 part per million alkalinity increase. So if we add 50 parts of a blended version, you won't see this dramatic pH change. You're simply going to see typically a slightly higher alkalinity. If your alkalinity is already high when you're adding this product, you may see a slight cloudiness when you add it, especially if you add it all at one time. We typically recommend splitting up the dosages of borates so that you avoid any moment of cloudiness if possible. So splitting it into 2 or 3 or even 4 doses. I have one of my favorite dealers down in Greenup, Kentucky. He has this 10-10-10 program. 10 part per million borates on opening, 10 on 4th of July, 10 on closing. His customers love it, and it's a great way to introduce borates and maintain borates on a regular schedule because, again, it's a preventative, and it's not, you're not solving an existing problem. You're just preventing any of these problems from ever happening. And it's also a way to add borates to the water where we never have that moment where we might have a chance of having cloudiness. So I love that program, and those guys do a great job of it down there. Again, you can always lower the alkalinity first so that you're not fighting it on the back end of it. All right, let's talk quickly about, let me check what time it is. Oh, adding borates to your business. Service, introduce it gradually and put it into all the pools you're servicing. It'll help you maintain the pool so you don't have to do work. Introduce it after acid treatments. It's the best pH alkalinity increaser that money can buy because it also adds the other elements to it. Introduce it to customers to improve their water long term. If you are a retailer, introduce it. Oh my gosh, when you're building a pool, when you're adding a liner replacement or filling a pool, add it then. Add it, recommend it as a chlorine reduction plan to customers. Introduce it as a winterizer, and it's tremendous for spas. We didn't touch on it at all, and it's great for spas. And just to point out, this is where borates fit into the pH spectrum. So this at 7, you have a borate, a blended borate, and at the tetraborate, the activator you see on the screen, that's at about 9.2. So that's an idea of these are where the pH of these products line up from left to right, the acidic to the basic products. So you get an idea of a blended borate product. That Supreme Plus is just right exactly where you want it for the most comfortable water. So Scott, I'm going to end it right there. Hopefully folks are scrambling to find a TV to watch Tigers, Indians all across the country. I know baseball is booming. And I know folks want to enjoy the rest of their day. It's 85 degrees here in Michigan, and it's a pleasure. I got a lot more I can talk about. We can go on for hours and hours, but I know Scott has to get away. He has a very late lunch, and I've enjoyed this immensely. So feel free to reach out. Scott, how do folks who have questions reach out after this presentation is done?
Well, they sent them to me, and I tried to organize them, and I'm just going to answer a few of the most prevalent questions. We probably had 10 questions from people saying, how do I get this webinar, a recording of it, and it will be free and available to all registered attendees after within 24 hours of the completion. So you will be able to get all these slides, all the whole thing as a recording for free. We had a lot of questions about dilution of the water due to rain or makeup water and how that affects borate concentration, but I think you answered that pretty well later in the webinar. So I'm assuming those people are satisfied. Um, and we'll end it with one last question. And maybe you answered this. How do you test for borates?
Borate tests are very easy. Manufacturers make test strips,
Okay.
and
Yes.
they can also get a classic a spin disc. But the test strips, they come in packs of 5 to 20 because you're not testing it very frequently. It does not take a lot of strips to get you through a year. So if you're a dealer that has 5 to 10 customers on it. It's a fairly easy investment in terms of testing because, again, it's not something that you should be testing for frequently because it just simply does not leave the water. So there's no reason to test for it other than once per year.
Excellent. Okay, I think that's all we have time for today. I want to thank you, John, for that informative hour. I learned a lot. I want to thank everyone for coming to the webinar. And we'll leave it there. I know everyone's got a lot left to do today, so let's get back to our pool business. See you next time.
All right. Thanks, guys. Thanks, Scott.